Hi everyone, thank you so much for having me today. My name is Simon, and joining me are my two teammates, Terry and Michael, and we're the silver winning team in the physics division in the last STO High School Science Award Asia. And it is truly an honor to be invited back as a speaker for this online science talk. When we first started our project, we never imagined how this would lead us to a medal, a journey to Tsinghua University, and now to have the chance to share our journey with so many talented scientists and enthusiasts across Asia. This feels incredibly special. And today I'd like to take you behind the scene of our journey in the Research Award, how the idea first came about, the challenges we faced, what we learned from together as a team, and some of the key lessons that helped us to turn curiosity into a complete research project. And I hope our story can inspire some of you as you prepare for your own entries or simply just explore your passion for science. So let's get started. So how this whole project actually started? It was an incredibly small observation, almost comical from hindsight. So in an ordinary school day, my teammate Terry accidentally spilled water onto his school uniform, and the water soaked into the fabric. We noticed something we've seen 1,000 times. The wet spots looked noticeably darker than the surrounding dry area. And the contrast was really striking. The dry area stayed bright, but the soaked area has a deeper shade. At first, it just seemed like a ordinary everyday thing. Who hasn't spilled water onto their clothes and watched the color change? Most people would shrug, dab it dry, and move on. But that day we paused. We asked ourselves, why does that happen? What physics is really behind that simple observations that so many of us just pass and forget? And that curiosity sparked everything. We started digging into the existing studies and literatures for the so-called the wet dot problem, the phenomenon where porous materials like fabric, paper appears darker when wet. And we found plenty of current theories explaining it through optics, such as total internal reflections, scatterings. But however, the basic mechanism is widely understood and explained, but there were still open questions, especially about the exact scope and limitations of these theories and models when applied to real-life situations, such as the fabric of the clothes, that surprisingly has rarely been modeled. And thus we believe that this will be a great entry point, not inventing the wheel, but revising and testing the theories in a practical and accessible way. So it then became our research project of the revise and research of the scope of the wet dot problem. And from there, the real journey begins. A lot of experiments, simulations, and late night discussions. And I believe my teammate Terry has some technical issue with his Zoom account, so I'll proceed to cover his part. So then we basically identified that the current theories has some limitations that could not be applied to real-life examples. So we believe that we could try to integrate the current theories and build up the strength while try to reduce the limitations, and so that it could be realistically used. So we basically combined the three parts of optics theories and came out um, just a rough final equation. And however, we still identified that there is some huge limitations after this integration. There are oversimplified geometry, simplified physical process, and extreme difficulties in actually obtaining the parameters. And so we decided to reflect on this process and try to think about what could be done next. What would be a better way to solve this problem and make it a actually applicable process and theory. And so through some further research and a lot of discussions between teammates, we later introduced some other theorems to more accurately to depict the phenomenon and get a final result. But after experiments, I believe reflections is always a crucial thing to do, and through reflections, and we still identify various limitations that could be found after this, although more accurate results. There is high cost and the difficulties to access to parameters and stuff. But um, after all, it is really a great experiment. Although there are still identified limitations of the final results, but we have already proceeded into a better place from the original studies and current theories that has far less accurate and unrealistic assumptions. And then one more thing will be the further improvement. After reflections, a the and the reflections could always lead to further improvements. And although due to time limits, we couldn't really proceed any further in the competitions, but identifying improvements would definitely help you to support your future science research and modeling process. And of course, the applications. But finally, let's talk about our journey in the competition itself. You know, walking into the room for the oral defense, it's really heart pounding, like, facing the judge panel. And those professors are some of the most outstanding scientists in Asia. They're true experts. And as high school students, we were definitely really scared standing in front of them. But here's something quite counterintuitively that we discovered. They were actually incredibly supportive of our ideas. They understand that high school research isn't going to be perfect. They know that we're still learning about scientific modeling and experimentations. Yes, they ask critical questions, the sharp ones that make us think hard. But those questions were surprisingly inspiring. They actually spark new ideas that we haven't thought anywhere, highlighted angles that we hadn't reflected on before, and gave us a multi-skilled expert perspective on our own work. And in the end, it wasn't an evaluation, it's just a tremendous learning and improvement opportunity. And facing those challenges head on, what kind of rigorous feedback pushes us to grow in ways we never expect. So then I'll invite my teammate Michael to talk about his experience in the YHSA Science Award Asia. Thank you.
Right. Good morning, or good afternoon, everyone. It's an absolute honor to stand here today. I'm Michael, and looking back on our journey from the STL High School Science Award, it feels like only yesterday that my team and I were standing at a blank screen, wondering how to turn a complex physical phenomenon into a structured research paper. To have walked away with a Continental silver medal was a milestone for us, but the growth we experienced behind the scenes and the people we met along the way was the real prize. I'll be honest, the early stages were not smooth. When we were creating our first draft and initial presentations, we hit two major walls: time management and team coordination. In the beginning, we worked individually. We had brilliant ideas, but no unified direction, leading to fragmented first drafts. And we realized quickly that working hard wasn't enough. We had to work together. So how do we solve those two problems? First, we began holding regular meetings twice a week to share current progress and discuss the next steps for our further meetings. And also, we devised a shared timeline planning document. This ensured every simulation and the slide was accounted for. So here's an advice for the younger generation. So keep a rigorous track of your time and progress. Research is unpredictable. Do not wait until the last minute to make corrections. Start your revising and correcting process early so you have room for the unexpected. All right. Now, when we entered the continental round and presented to the panel, the judges discovered a significant flaw. More specifically, we had not accounted for the thin film interference effects in our theoretical framework. At first, it was daunting to hear our theory was incomplete. However, this is the beauty of the SEL competition. We immediately integrated the interference effects, and this refinement drastically improved our accuracy. This taught us that scientific research is a continuous cycle of discovery and refinement, whether it's through your own checks, your teammates, or the judges' expert comments. Every problem discovered is an opportunity for a better version of your work. Beyond the physics, one of the most rewarding aspects of this prestigious competition is the community. During the global finals at the Tsinghua University, we had the unique chance to get to know and learn from other excellent scholars and students who share the same passion for physics. Seeing the diverse ways other teams approach their problems was incredibly eye-opening and inspiring. Lastly, I want to extend my deep gratitude to Professor Shintong Yao, SDL competition officials, as well as the volunteers engaged in this activity. Thank you for providing us with a platform that regards high school students like professional researchers. To the judges, thank you for your helpful comments. You didn't just grade us, you mentored us. To the future participants, lean on your teammates, learn on your teammates, and embrace the feedback. The STL competition doesn't just teach you physics, it teaches you how to be part of the global scientific community. Thank you.